And so we also tend to do things a little different. So the non-conservative forces are generally not there, so they don't do any work. Pretty much every problem. Spelling is hard today. So we almost always have our conservation of mechanical energy. And the issue is that instead of working with work non-conservative is delta E, we usually go up to this line here. So we usually go so like this mid-step here is usually where we start. And then we've argued that the non-conservative forces don't do any work because we don't really have any, because we have like electrons or something. And so then this is the way we write down mechanical energy. Usually we write it the other way around. So we write it the other way around, then we get that the change in the kinetic is minus the change in potential. This is usually how we do our work, our conservation of mechanical energy. In physics too. We almost always start here. Okay? And that's because in a lot of cases we won't necessarily know individual values of the potential energy function, but we'll note changes. And so we don't usually go through the habit of let me pick where all the zeros are. And it makes it a little more expedient. So you don't set energy equal to energy, you set this change equals that change. Now I always read this if you just look at the ball. You know, what I did was I traded height for speed. Or you can trade speed for height on the way up. I'd throw it, but I probably couldn't catch it. Okay? So that's kind of the deal. Okay? Then what we get is that since the gravitational force is conservative, then, yeah, you can. Thank you. Then the electric force is also going to be conservative. And so then it's going to have a potential energy function. Okay? Okay? And then the basic concept here and what will happen is we're going to define the energy per charge similar to how we defined force per charge. With the electric field. Okay? And so our definition for the electric field was that it was the force per charge. Okay. And then what we'll get is that our electric potential will be our electric potential energy per charge. And I can't remember, did they put a prime on the Q? I think they did. I think this is the notation. So V is our electric potential. Again, notice the absence of the word energy, and U is our electric potential energy. Anytime they want to talk about U, they will make sure they say the word energy. So you just got to be really careful with the verbiage, okay, and keep an eye out for that, okay.